Good afternoon, guys. My name is Grant Foster. I want to present my preliminary abstract for Project 1. It's based on the modeling of a Segway control system. This is a Segway. I'm sure we've all seen one. Basically, it's a two-wheeled electric device designed for transportation over relatively short distances, and it serves as a green alternative to other small vehicles and recreational vehicles such as mopeds, motorcycles, automobiles, etc. The way it works is it's based on the classical control problem of the inverted pendulum. It uses electric motors in each wheel, which are powered by lithium-ion batteries. The balance is maintained using tilt and gyroscopic sensors that sense when the operator leans in one direction or the other, which is the input, and the wheels are responding to that signal by moving forward or backwards to return the pitch to the upright position, which is the output. You can kind of see that depicted here in the very first skeleton guy. He's in dynamic balance or dynamic equilibrium. As he leans forward, he forces on the Segway. The Segway senses his tilt, and it responds, which the Segway forces back on the rider, and the way that it does that is by changing the direction of the wheels. And at the end there, he is back in dynamic balance. It is considered an open loop. The rider would be considered the actuator in this instance. And there's a microprocessor inside of the housing there that does the sensing and calculating on exactly what angular displacement the wheels should go. So I became interested in this project basically after seeing these machines in use. I've always kind of had a curiosity about how this control system operates internally, and I've never really had a chance to explore that until this class, so that's the reason that I chose this project. The applications of this system thus far have been widely used in policing, emergency medical, industrial warehouse transportation, recreation, and several other sectors. There have been some works and plenty of studies and simulations done. One of the main ones that I found was done by the Georgia Institute of Technology in 2012. What I wasn't able to find was a MATLAB program and a Simulink model. So that's what I plan on including in this project. It is basically a MATLAB program in which you can designate the variables of, there's several of them, that some of them include the mass of the rider, his height, the wheel radius, the inertia of the motor torque constant, and there's, like I said, there's several others. Those functions will be the input and input into the MATLAB transfer function, at which point you can it will provide the resulting output, so the system responses. And then the Simulink simulation will be given as well, and that will be, it's kind of a block diagram that will be used to simulate the open loop step responses. I'll also estimate the control parameters using the root locus control design, and sketch the roots, the poles and the zeros, that is, of the system using MATLAB plots and graphs. And what I hope to achieve in this project is a mathematical model of the system, as well as a simulation of that model that can be used to analyze system response, gain, and error. And thank you for your time. Have a great day.